Okay, we're still working with the law of cosines in section 3.2, and we're going to do an example now. If you have all three sides given to you, you can also use the law of cosines to calculate the angles. Okay, so what we're going to do is we're going to use the law of cosines here a couple of times. So here's my triangle and my sides given to me. So this is side y, this is side x, and this here over here is side z. Okay? So now what we're going to do is we're going to apply the cosine law. So we're going to deal with we're going to try to figure out here angle z. Okay, so we'll write the formula out first. Z squared equals the two included sides squared, so that would be equal to side y squared plus side x squared minus twice the product of those two sides, 2 times y times x, times the cosine of this angle here, cos z. Okay, and we want to calculate cos z now. So now we plug our numbers in. So z is 12 squared is equal to y squared is 10 squared, we'll just write about, plus 16 squared minus 2 times 10 times 16 and cos z. Okay, now we can work this out and isolate cos z. So 144 equals 100. Now 16 squared, we have to get that here. That's 256. Minus, okay, that's 160 times 2. That should be 320. 320 cos z. So I'll bring all the numbers over to the left side so that cos z is by itself. 320 cos z is by itself. Okay, so 144 subtract 356, because that adds up to 356. So 144 subtract 356 equals negative 212 equals negative 320 cos z. Divide each side by 320 negative. Okay, so cos z gives you a decimal number. Now I'm going to do it on the calculator here. So divide by 320 negative. So I should have a positive number. It gets me decimal 6625. So convert that into an angle by using second function on your calculator for the cosine. And I got 48.5. We'll go to one decimal place on the angle. 48.5 degrees. Now I have that one. Now I can calculate one more of the angles. I'm just repeating myself by repeating this again, but just moving over to one of these other two. I'm going to move over to x here. So let me just center that a little bit. Make sure it's centered in there. Okay, I'll leave it here for now while I write out the equation, then I'll move it up. Let's do x. So let's pretend now x is out here. So we're going to find angle x now. So x squared is going to equal the other two sides squared. So this time, I'm just, instead of putting the formula down, I'm going to put the two sides beside it here. So it's going to be 100 squared plus 12 squared. So I guess I should have put 16 squared here. Actually, you know what? I should write this down. It's x squared, just in case, we might get confused otherwise. Myself included. Sometimes I'll confuse myself. So this would have been x squared. This would have been y squared plus z squared minus 2yz cos of x. Okay, so there we go. So minus 2 times y times z and cos x is unknown. There we are. So we have similar numbers to work with. So this is still 256 here equals 100 plus 144. This here is 120 times 2, that's 240 cos x. Okay, now I'll move that. I better move that up. And we just isolate cos x. So this becomes 244. So this becomes 256 minus 244. That's 12. Okay, we see that this time we're going to get a positive number on here. So we're going to get a negative value. That means it's probably going to be over 90 degrees. So my diagram might be a little erroneous. Okay, so here we are. Divide by 240. Negative 240 on both sides. And here we are. 12 divided by 240 negative. Decimal 0.5 negative. Take the cos of that. Cos x equals negative 0.05. X equals shift cos 93 or 92.9 degrees. Okay. All right. How can we find the next angle? Well, the last angle y, we can just add these two angles up and subtract them from 180. So angle y equals 180 subtract 92.9 subtract 48.5. So take our calculator out to get angle y is equal to. So clear this. Of course, hopefully it'll hopefully there's no rounding errors in there. There might be a decimal off or so. That's why I don't like rounding till the very end. But if we had this minus 92.9 minus 48.5, so it's going to be 38.6. And that's how you can use the cos law to calculate and find all the angles if all three sides are given in a triangle that's not a typical right triangle. Now there are some word problems that you can do with it as well, but the only difference here is you have to draw a diagram first of all, and I think you can handle that. I think I'll save doing some word problems till later in the unit when we do combining all the triangle solutions together.